Alright, today we're going over Algebra 1 6.1 notes in the Big Ideals textbook. So what you need is a pencil and your student journal. Go ahead and open up to 6.1 now and you can follow along. Alright, we're talking about exponent properties. The first property we're discussing is the zero exponent property. What this property does is it says that any number that is not zero, taken to the zero power, will always be 1. So 4 to the zero power is 1. 8 to the zero power is 1. You could do 513 to the zero power, it will still be 1. The only exception to this rule is 0 to the zero power, and that is undefined. The next property we're talking about is negative exponents. What this says is that when we have a number, it can't be 0, but when we have a number here, taken to a negative power, all right, a negative power of a whole number, then the answer is the reciprocal. So 4 to the negative 2, picture this as 4 to the negative 2 over 1. The 4 to the negative 2 is on top of the fraction, so it moves to the denominator of the fraction and the power becomes positive. For example, if we had 3 to the negative 8, that would become 1 over 3 to the 8th power. All right? For example, we could also have 5 to the negative 13th. That would become 1 over 5 to the 13th. So the negative power moves the number to the opposite side. So if it's on top, it moves it to the bottom. If it's in the denominator, it moves to the top, which is the numerator. All right. Here's examples. 6.7 to the zero power. Remember, any number other than 0 to the zero power is always 1. On this one, this is the same as taking 1 over negative 2 to the 4th. All right, you keep the negative 2 in parentheses. Go ahead and type negative 2 to the 4th in your calculator. Make sure you use parentheses, otherwise your answer will come out negative, which would be wrong. So negative 2 to the 4th is 16, so this answer is 1 over 16. Alright, look at your student journal on page 172. Go ahead, pause this video now and do numbers 1 through 4. Alright, so you should have paused the video. 3 to the 0 is 1. Negative 2 to the 0 is still 1. 3 to the negative 4, this is using our negative power, and so we bring it down here, 1 over 3 to the 4th. And then negative 4 to the negative 3rd, we do 1 over negative 4 to the 3rd. Now on all of these, we can go ahead and we can find out what the answer would be using a calculator. So, for example, you can go ahead and type in your calculator 3 to the 4th power, okay? So you're going to do 3 to the 4th. And you should find out that that's 81, so this answer is 1 over 81. On this one, when you do negative 4 to the 3rd, just make sure you plug that negative 4 in parentheses, and then do to the 3rd power. That's going to come out to be negative 64, so this answer is 1 over negative 64, or negative 1 over 64. Same thing right there. Okay. Here's just another example. This isn't in your notes, so you can just follow along. So it says simplify this expression using only positive exponents. So start up here. When we have x to the 0, we know that that becomes, right here, this x to the 0 becomes 1. So this basically is 4 times 1, which is 4 on top. So now we still have y to the negative 3. So remember, what a negative power does is it moves it to either the opposite side that it's on the fraction. So this is on the denominator, so the power is going to move it up to the numerator because it's positive. So our answer is 4y to the 3rd. Okay, go ahead and pause this video and answer number 5 through 8 in your student journal, and then go ahead and play the video to check your answers. Alright, on this one, we can start just by saying that this is 1. So this is the same as 2 to the negative 3, which now you know using negative exponents is the same as 2 to the 3rd. And once again, if you want to go ahead and simplify it all the way, you can go ahead and you can put it as 1 over 8. And you need to know how to do these without just typing them in the calculator, so make sure you're using your exponent properties. Alright, on this one, you're going to go ahead and you have negative 3 to the negative 2. Now, it's very important to note on this one that the negative is not in parentheses. You do not see this on your paper, okay? So when we do this one, think of the negative outside and think of this just like that. So the negative is going to push the 3 to the bottom, so we're going to have 3 squared on the bottom. And the negative on the negative 3 right here is going to push the 2 cubed up top. So we can type this in our calculator, and we know that 2 to the third power is 8, and 3 squared is 9. And so you have negative 8 ninths, and that would be our answer. All right, over here, same thing. This is not in parentheses, so you do not see the parentheses around the negative 7. So down here on the bottom, what is becoming negative is just the 7 to the 0. So you still have the negative, but this portion right here is what becomes 1. So that's why it's over negative 1. So from here, you have 4 to the negative 1, which we know then takes this entire thing and brings it down here. So we have 1 over negative 1 times 4 to the 1 power. Well, 4 to the 1 power is just 4. So negative 1 times 4 is negative 4. So your answer is 1 over negative 4, which is the same as negative 1/4. Over here, I like to start with this one. It's really easy to do the 0 property. So when it's to the power of 0, it becomes 1. So we can rethink of this as 3 to the negative 1 over 1, which we know this negative property is going to push it down here, and you're going to have 3 to the first power here, which 3 to the first power is 3, so this is the same as 1/3. All right, the next property we're going to look at is the product of powers property. So the key here is that your base has to be the same. So notice that the base is 4 on both of these. The exponent can be the same or it can be different. That really doesn't matter. So what it is when we have the same base, so the base is 4 on both of these, and they are being multiplied, we can add their powers. So 4 to the 6th times 4 to the 3rd, we can take it 4 to the, and then add the powers. 6 plus 3 is 9. So it's the same as 4 to the 9th. So for example, if we had 5 squared times 5 to the 10th, we would just take the powers and add them, and we'd get 5 to the 12th. This only works if the base is the same. So for example, if you have 4 to the 6th times 5 squared, this rule does not work. It has to have the same base. The quotient of powers property is very similar. Same thing where you have to have the same base, but in this case, quotient is dividing. So the numbers are being divided. When that happens, you just subtract the powers. So 4 to the 6th over 4 cubed, you're going to take the powers and you're going to subtract them, and you're going to do 6 minus 3. All right? That's how you get 4 cubed. So for example, we could do 8 to the 5th over 8 squared, and we do 8 to the power of 5 minus 2. 5 minus 2 is 3, so it's the same thing as 8 cubed. Now, the final one on this slide is the power of a power. So when you have something to a power, and then it's taken to another power, what you do is you multiply the powers, all right? So you actually take 4, and then you take 6 times 3, and you get 18. So for example, if we had 5 squared to the 5th power, we would multiply the powers. 2 times 5 is 10, so it would be the same as 5 to the 10th. The reason that works is think about 5 squared to the 5th. To the 5th power means that you are multiplying 5 squared times itself 5 times. So you have this, and in this case, this resembles the product property where we add them. 2 plus 2 plus 2 plus 2 plus 2 equals 10, but that's a lot more effort, so that's why it's great to have this property. All right, so go ahead and let's look at these examples. These aren't in your book, we're just following along, getting a little more practice in. So it wants us to simplify them and just write the answer using positive exponents. So we don't need to go ahead and type it in our calculator, we're just getting it as simplified as possible. So on this one, the base is the same and they are multiplying. So what we do is we add the powers. So 2 plus 6 is 8, so the simplified expression is 3 to the 8th. On this one, the base is the same, both bases are negative 4. And so since it is a quotient property because it's being divided, we subtract the powers. Now you always subtract the top power minus the bottom power. So we're going to do negative 4, and then we're going to do 2 minus 7. And so we get negative 4. 2 minus 7 is negative 5. So now we also have to use our negative power property, which basically tells us to move it to the other side. So this is negative 4 to the negative 5th. So it's going to become negative 4 to the positive 5th, and it's on the denominator of a fraction. So this would be our answer right here. And we are done because it said use positive exponents, which we've done. The 5 is positive. It didn't say that we had to go ahead and simplify it further. All right, on here, this is a power to a power. So remember, what we do when it's a power to a power is we multiply them. So 4 times negative 3 is negative 12. So now we want to use our negative property, which tells us to take it as 1 over z to the 12th. And this is our answer right here. All right, so let's go ahead and take a look. These are a few more examples. You're more than welcome to skip past this to the next page where we work on your student journal, but if you need more help, I'll walk you through these. This is 10 to the 4th times 10 to the negative 6th. The bases are the same, they're both 10, and they're multiplying, so what we do to the powers is we add them. So we get 10 to the negative 2, which we then have to use our negative property, and we get 1 over 10 squared. Over here, same thing, we add these, so we get 9 plus negative 9, which we know is 0, and anything to the 0 power is 1. All right, on these, I'm just going to go ahead and skip down to this one. I think you guys are pretty good at this, so I'm going to go ahead and do number 8, and then I'll go ahead and do number 9, but I think you guys are probably fine on 7 and 10. So number 8, we're going to subtract. Remember, you do the top power minus the bottom power, and we can do this because the base is the same. So we get y to the negative 1, which then becomes 1 over y to the 1, and you don't have to write it when it's 1 power. You can just do 1 over y. That's the simplest way. This is a power to a power, so we multiply them. So negative 2 times negative 1 is positive 2. So we just leave it as 6 squared. Technically 36 is good too, but it said we could just leave it with positive exponents. All right, so a few more things just to take care of. This is just showing you that you can kind of go backwards here. So this is the power of a product. So when two numbers are being multiplied and taken to the power, we can rewrite them separately. Okay, so what this means is like if you have 2x in parentheses taken to the third power, this is the same as 2 to the third power times x to the third power. And so then 2 to the third power is 8, x to the third. The other thing is you can go backwards with this. You could say, okay, I have 3 to the 5th and I have y to the 5th. So I can rewrite this as the quantity 3y to the 5th power. All right, down here, same thing just with quotients, all right? If it's in a fraction, we can distribute that power to both the numerator and the denominator, all right? And then we can also undo it. So if we have 2 over y to the power of 7, we can take that as 2 to the 7th over y to the 7th. We can also go backwards with it. We can say, all right, we have 3 to the 8th over 5 to the 8th, and I can say that is the same thing as 3 over 5 in parentheses to the 8th power. All right, here's some more examples. I'm going to go ahead and do 2 of them, but I feel like you guys are probably doing pretty okay at this point. So this one, I can sit here and I can take negative 1.5 squared times y squared. All right, and it says using only positive exponents, I can go ahead and simplify it down, and I can just type it in a calculator and do negative 1.5 in parentheses and then squared, and I'm going to end up with 2.25. So I could call this 2.25 y squared, and that's our simplest way to write this. Now also right here, I can distribute the 4. Now keep in mind when you're distributing it, it needs to go to everything. So when you have 3d to the 4th, if you write it like that, you're not doing it quite right, because it's not just going to the d, it's going to the 3d. So it's like this, 3d to the 4th. So now think about it, it's 3 to the 4th, d to the 4th, and still over 2 to the 4th. So at that point, you can go ahead and you can just type in your calculator 3 to the 4th, okay, and you get 81, d to the 4th, and you can do 2 to the 4th, and you get 16. And you can go ahead and leave your answer like that. Go ahead and pause this video and complete student journal. We're going to complete numbers 9 through 14 and then come back and we'll look at them. Alright, hopefully you got z to the 0 is 1. A to the negative 8 is 1 over a to the 8th. Those two are pretty easy. Now we come here and we're combining them. We have 6. A to the 0 is 1. B to the negative 2 is 1 over b squared. So 6 times 1 is 6 over b squared. And that's our most simplified answer. Over here we have 14. M to the negative 4 is 1 over m to the 4th. N to the 0 is 1. So we look at this. On the numerator of the fraction, we have 14 times 1, which is 14, over m to the 4th. All right, this one gets a little more difficult. My suggestion would be to start just with the s to the 0 and knowing that it's 1. and then rewrite this as 3 to the negative 2 times r to the negative 3. So if you think about 3 to the negative 2, it's going to become 1 over 3 squared, and r to the negative 3 is 1 over r cubed. You can just write those as one fraction. You can go ahead and simplify if you'd like. 3 squared is 9, and so you have 1 over 9r cubed, just like that. All right, once again, just take your time on these. They get a little more complicated, but it's not terrible. C to the 0 is just 1, so that can go away. 2 cubed is 8, so you have an 8 right there. Now, think about this. The negative 3 pushes the a to the bottom, so that's going to move down here, a cubed. The 8 to the negative 1 is going to push it to the top, so it's going to be 8 to the 1 power. The b to the negative 5 will also push it to the top and be b to the 5th. So we come out with 8 times 8, which is 64, b to the 5th, over a cubed. All right, go ahead and complete number 15 through 20 in your student journal. Pause the video and then come back and see how you did. All right, this is using the quotient property. So you can do 5 minus 3 because they are the same base, and so you get 3 squared. We can go ahead and leave that as 3 squared because it did just ask us to write our answers with positive exponents. Same thing here. You can do negative 2 and 7 minus 5, and so you get negative 2 to the 2nd power, which once again you could square it and get 4, but this is fine. Just go ahead and leave it at this point. Over here, these are the same base, so what we are going to do to the powers is we're going to add them. So we're going to leave the negative 5 in parentheses. 3 plus 3 is 6, so it's negative 5 to the 6th power. This is a power to a power, so what we do with the powers is we multiply them. We get 5 times 3, and so we get q to the 15th power. Same thing here, this is a power to a power, so we multiply them. We get a to the negative 8, which we then use our negative property to drop it down to the bottom. And that actually shouldn't be a negative. Once we've moved it, we need to go ahead and need to make that a positive. Sorry, guys. All right, and so over here, let's start on the top. C to the 4th times c cubed. You add the powers, so you have 4 plus 3. All right, 4 plus 3 is going to be 7, so we have c to the 7th over c to the 6th. So now it's a quotient property, so they have the same base, so we take the top power minus the bottom power. So we get 7 minus 6 is 1, and c to the 1 is the same as just c. Okay, so over here we need to distribute this power, so we're going to have negative 4 to the 4th times d to the 4th. So now we can either go ahead and leave it like that, or we can go ahead and take it to the 4th power, which is 256 d to the 4th. So now here we can take negative 3 to the negative 3 and f to the negative 3. All right? What that does is that's going to go ahead and bring the negative 3 to the 3rd to the bottom and the f to the 3rd to the bottom. So we can then type in negative 3 to the 3rd power, and we know we're going to end up with negative 27. So we get 1 over negative 27 f cubed. Or we can pop the negative out to the side either way. So here on this, we get 4 to the negative 3rd, x to the negative 3rd. The negatives are just going to make them move, so the negative 3 brings the x up here and the 4 down here. And once again, we go ahead and leave it there. We can go ahead and type it in, and we get x cubed over 64. All right, and this is number 24 on your student journal. So it says a rectangular prism has a length x, a width x over 2, and a height x over 3. Which of the expressions represent the volume of the prism? And select all that apply. So the volume is going to be length times width times height. So we're going to take x times x over 2 times x over 3. So we're going to with x times x times x is x cubed. 2 times 3 is 6. So we want to see what is equivalent to x cubed over 6, and it could be more than 1. So if you think about this, 6 to the negative 1 is going to bring the 6 to the 1 power over down, and so then 6 to the 1 is just 6. So a is the same as x cubed over 6. So now let's look at this. The 6 to the negative 1 is going to bring it to the bottom, and then the x to the negative 3 is also going to bring it to the bottom. So this is not the same because it's 1 over 6x cubed. So then here, the negative, we can do this multiple ways. There's more than one way to solve this. So you can go ahead and you can distribute the negative to everything, all right? Or you can go ahead and you know that if it's to the negative, then it's the same as 1 over 6x to the negative 3 to the positive 1. All right? So there's more than one way to do this. You'll see me do it multiple different ways. That's the same as this. Now keep in mind, the x to the negative 3 needs to then move to the top. The 6 is not 10 negative power, so it stays on the bottom. So this is also the same as x cubed over 6. All right, so on this one, 2 to the negative 1 is 1 over 2 to the 1 power, which is just 1 over 2. 3 to the negative 1 is 1 over 3 to the 1 power, which is just 1 over 3. And then this is x cubed. So when we go through and multiply them, on the top we have 1 times x cubed, which is just x cubed, and 2 times 3, which is 6. All right, so this is the last one that I want us to do. This is not in your notes, but it does show up in your homework, so it is important. If you'd like to go ahead and pause the video and write it down, there's some extra space by the vocab. It'd be a great place for it, but it definitely does show up on things, so make sure that you're not just skipping this one. So it says that a jellyfish emits about 1.25 times 10 to the 8th particles of light, or photons, in each 6.25 times 10 to the negative 4th second. So how many photons does the jellyfish emit each second? It wants us to write our answer in scientific notation and in standard form. All right, so we are talking about photons in each second. So think of that as photons over seconds, and that's what we're trying to find. So if we write photons, 1.25 times 10 to the 8th, over seconds, which is 6.25 times 10 to the negative 4th. Let's just start with standard form, all right? Standard form is pretty easy. We can go ahead and just to check it out, we're going to try it this way. If you take 1.25 times 10 to the 8th, you're going to move your decimal place to the right 8 places. So there's 2 places. There's 2 more, so we're at 4, 5, 6, 7, 8. And negative 4th means we're going to move our decimal place to the left 4 places. So we're going to move it to the left, and so we'll be at 0.625, that's 1 place, 2, 3, 4. So now if you were to just take a calculator and if you were going ahead and divide it, so you have 125 with 6 zeros divided by 0.000625. Then I end up with that you have 2 times 10 to the 11th. All right, so in that case, that is going to be in scientific notation, all right? Let's go ahead and let's look at another way to do this and see how we can get to scientific notation, and then we'll write it in standard form. So another way we could think about this is we could go ahead and we could do 1.25 divided by 6.25. I get 0.2. And then if you have 10 to the 8th over 10 to the negative 4, if you think about that as the quotient property, you subtract them, 8 minus negative 4 ends up being 12. So it's 0.2 times 10 to the 12th. But we know that we never write our first number in scientific notation as 0.2. It always needs to be between 1 and 10. So if we move the decimal place to the right to get 2, that's where we come up with 10 to the 11th. All right? And then in standard form, that's going to be 2. And then we're going to move the 0 to the right, the decimal to the right 11 places. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. So we are saying that, get all of our comments in there correctly. All right, the jellyfish emits, and so this is going to be 200 billion photons of light each second. All right, thank you for watching this. Be sure to ask questions, write down questions in your notes, and if for any reason you just got stuck or you zoned out, feel free to go back and watch the video again, or just portions of it that you didn't understand. Thank you and have a great day. I'll see you in class.